See, I'm just going one step ahead and I'm just starting with the LU decomposition, but here the case is different. Here you can see that if the matrix A is non-square type, means it is purely rectangular type, then how we perform LU decomposition of matrix A. So here, if I will try to write A as the product of lower triangular and upper triangular matrix, where L is assumed to be lower triangular matrix, lower triangular matrix, and U is assumed to be upper triangular matrix, upper triangular matrix. So now if you see that if your matrix is non-square, means it is purely rectangular in shape and size, means it is of the form of m by n. The size of A is m by n, where m and n are not equal. Then instead of requiring upper triangular matrix, we only put restriction by requiring U to be a matrix in row echelon form. So here what I assume that U is a matrix in row echelon form. Okay, so it is, instead of upper triangular matrix, it is a matrix in row echelon form. So let us see and try to work out some problem so that we can handle such type of matrix. So let us take one example. See, find LU factorization of the matrix. Find LU factorization of the matrix. See, my matrix is 1, 2, 0, minus 1, 1, minus 2, minus 7, 3, 8, minus 2, 1, 1, 3, 1, 1, 3, 5, 2, and finally 0, 3, 3, minus 6, 0. So you can see what is the size of this matrix A. Suppose I want to find LU factorization, but the restriction on A is that A is non-square, A is rectangular in size, means how many rows it have? See, 1, 2, 3, 4. You can see 1, 2, 3, 4. It has 4 rows. And how many columns? 1, 2, 3, 4, 5. It has 5 columns. Means it is of size 4 by 5. Right? Whatever method we work, that was applicable for the matrix of size n by n. But here we have something different. We have a matrix of size 4 by m. And I want to apply the same decomposition method, but here instead of U being a form of upper triangular, U is assumed to be a matrix in row echelon form. So now let us see how we will work out with this. Right? First of all, we will see how we can work out with this matrix and find its LU decomposition. Okay. So now let us try. What is I will write L, and can you tell me what will be the size of L? Can you tell me what will be the size of L? See, it is 4:5, right? What will be the, I am going to write A as a product of L into U. So can you tell me what will be the size of L? What will be the size of U? See, U is obtained from A by applying elementary row operations. So U and A matches with the size. So I will say that size of U is 4 by 5, the same as that of A. The size of U is 4 by 5, same as that of A. But here the size of L should be, see here, because here is 4, so I will write 4 here and I will write 4 here, so that it is conformable for multiplication. See, it when you have two matrices of size m by n and n by L, then you can only apply it. That means number of columns of first matrix should match with the number of rows with the second matrix. So U, first of all, U have the same shape and size as that of A, and L I assume to be 4 by 4. So L here I am assuming 4 by 4. All right. And here what I will do, the diagonal entries I will take as 1, and above diagonal element I will take as 0. Okay. So it is 1, it is 0, this is 0, this is 0. So what are the places which we have to fill? That we have to see. By doing elementary row operations and choosing the multipliers as the number which has to be put in the proper position, we will be able to find L, and at the same time, our A will be reduced to U. So see, first of all, I want to make the entries below 1 in the first column as 0. See, I want to kill all the entries in the first column below 1, right? I want to kill all the elements in the first column below 1. That is my first task. And negative of the multipliers I will put below 1 in L. So you can see I will multiply 2 to first row. I will multiply 2 to first row and add it to second row, right? I will multiply 2 to first row and add it the second row, so that we will get 0 in place of -2. So what is the multiplier 2? So I will fill this position as -2. I will fill the position, corresponding position of L as the negative of multiplier, right? So let us start our work. You can see I have 1, 2, 0, minus 1, 1, and now see 2 into 1, 2 minus 2 is 0, 2 to 4 minus 7, that is -3, 2 into 0 is 0 plus 3 is 3, 2 into -1 -2, 8 minus 2 is 6, 2 1 is 2 minus 2, that is 0. So I will fill all the entries. Let us see whether it is right or wrong. Entries are 0, -3, 3, 6, 0. Next one, I want to kill the element 1 in the third row. See, I want to kill this element 1 in the first column of A, and in the in the first column and in the third row. So for that, I will multiply -1 to first row and I will add it to third row, right? So what is the multiplier? Multiplier is -1, right? Multiplier is -1, so I will put its negative, that is I will put 1 in the required position. So what I am getting, -1 plus 1, I am getting here 0. -1 into 2 is -2 plus 1 is -1. Next, 0 plus 3, I am getting 3. Minus minus plus 1 plus 5, I am getting 6. And -1 plus 2, I am getting 1. -1 plus 2. And you can see in the last row, the first element is 0. You can see A, where in the last row the first element is 0. So what will be our multiplier? No multiplier is needed at this end, right? Because I want here 0, so I will put dummy 0. I will multiply 0 to first row and add it to uh, fourth row. So I am getting here 0 and this is my matrix. Okay, so I will write here the elements. The elements are 0, 3, -3, -6, 0. Okay, so all elements I have written here. Next target is to make the element in the second column which is below -3 as 0. So I want to make this element as well as this element as 0. So what should be our multiplier? That is the question. So you can see I will multiply second row by -1 by 3 and add it to third row. I will multiply second row by -1 by 3 and add it to second row, so that I will get 0 in the second column and third row. Similarly, if I will multiply 1 to second row and add it to last row, I will get 0 where 3 is there. So I can see here that what I am going to get, say 1, 2, 0, -1, 1, 0, -3, 3, 6, 0, and see then 0, it is 0, minus minus plus, see minus minus plus, 3 and 1 by 3 is 1, 1 minus 1, 0, minus, if you do 3 getting cancelled, if you multiply this two, 3 getting cancelled, -1 plus 3 is 2, and then -2 plus 6 is 4, and here -1 by 3 into 0 is 0 and plus 1 is 1, and finally I will multiply 1 to second row and add it to fourth row. So it is 0, -3 plus 3, 0, 3 minus 3, I am having 0, 6 minus 6, I am having 0, 0, I am having 0. So all are 0 now. Now you can see here what is required here, right? So next couple of operations is giving you this much. So for this position, what is my multiplier? My multiplier is -1 by 3. So I will put here 1 by 3. For this position, what is my multiplier? My multiplier is 1. So its negative is -1. And one position required, but no operation is needed. See, For the place here, already I am getting 0. So, and I need 0 in that place. I need 0 in that place. So, what I will do, see, I will multiply third row by 0 and add it to this, and its negative is 0, so I will put here 0. So now you can see this is my U. This is my U. Okay? And this is my L. You see the diagonal positions? You see the diagonal positions? 1, 1, 2, 2, 3, 3, 4, 4. You can see all the elements below the diagonal entries are 0. You can see in U all the elements below the diagonal elements are 0. And when you see L, what is the beauty of L? L has ones on the diagonal, and second thing, all the elements above diagonal are 0. All the elements above diagonal are 0. So what type of matrix is this? Unit lower triangular matrix. I say it is unit lower triangular matrix. And what is my U? U is matrix in row reduced form. Matrix in row echelon form. Okay? So this way I can write A as the product of L and U. Any doubt? Asri Das, you have any doubt? Now, Sri Sai Venkatas Riman, do you have any doubt?
No, sir.
Is it clear?
Yes, sir. Yes, sir.
So see, I am just explaining once more, and what are the things which should be taken care of, right? First of all, when your matrix is non-square, so in that case, you have to take U as the matrix in row echelon form, right? You have to take U as the matrix in row echelon form. And L, we prefer to take a matrix which is unit lower triangular matrix, means ones on the diagonal and above diagonal entries are 0. Below diagonal elements can be anything, but I require ones on the diagonal and above diagonal entries are 0. Okay? And one thing which I want to say here that is extremely important, and that I am writing as a note. First of all, when you are performing elementary row operations, so there are 3 types of row operations. First, a scaling. A scaling means multiplication of a row by a constant. Second, interchange, that is interchange of 2 rows. And third, replacement, means a row is replaced by the sum of itself and a constant multiple of another row. So here, out of these 3 operations, only I will perform 2 operations, and I will not do interchange. So I will not do interchange, because in this case, if you go for the interchange, then your concept of lower triangular matrix will change. You will not get lower triangular matrix. So you have to avoid interchange. Interchange is not allowed. You can perform only scaling and replacement. Only scaling and replacement are allowed. Okay? Only scaling and in replacement are allowed. Only scaling and replacement are allowed. Okay? The second thing which you have to be very careful in the case when A is not a square matrix. If A is not a square matrix, if A is not a square matrix, we simply require U to be a matrix, U to be a matrix in row echelon form. Okay, so these are the two things which you have to be very careful. Okay, so now we will see one another question and you have to answer that question. You can see I am taking second question as my matrix as 1 0 1 minus 2, then 0 3 3 1, and finally 0 0 5. Now you can say me what type of matrix is this? What is the size of the matrix? What is the size of the matrix? Please reply.
3 cross 4.
3 cross 4 means it is non-square type. It is non-square type. And second thing, you have to find L, where L is unit lower triangular matrix. And second, you have to find U, right? And U is a matrix in row echelon form. Okay, so what you can do here, see, only if you look at your matrix, you can see here I have 1, okay, remaining all 0. Here I have 3 below 0, and here I have 0. So all the elements, see, what are the elements in 1 1 position 1, 2 2 position 3, and 3 3 position 0. So what are the elements below these diagonal elements? All elements below diagonal are 0, right? All elements below diagonal are 0. So it is already in row echelon form. See, it is already in row echelon form. So your U and A will match. So I will write 1 0 1 minus 2, 0 3 3 1, and 0 0 5. Okay, and see your L. What is your L? Your L with the identity matrix 1 0 0 0 1 0 0 0 1. See, from here you can see size of U should be 3 by 4. So it is itself. So it is 3 by 4 size, and size of L will be 3 by 3. Right? So this is your answer. In case In case you are having upper triangular matrix as your matrix A, then there is no need to do any work, and only you do one thing. You write your L as the identity matrix and write U same as that of A. Okay? Shall I jump to another question? Shall I jump to another question? See, here we have question number 10. Right? I'm going to work out question number 10. So for question number 10, I will write the entries first. 2, 2, minus 1, 2, 2, minus 1, then 404, 404, and finally 344. 344. This is your matrix A, and you have to find LU factorization. And you know here that this is 3 by 3 matrix. This is 3 by 3 matrix. So L I can find as a matrix with ones on the diagonal. So I write 1, above diagonal element 0, then 1, above diagonal element 0 and 1. So here we have 3 entries left which we have to fill. So now you can see, first of all, if you look at the A, you can see I want to make the element in the first column which is below 2 as 0. So I want to kill 4 and I want to kill 3. Okay? So I want to kill these 2 elements. So first of all, I will multiply -2 to first row and I will add it to second row. Okay, so I will get 2 to minus 1, and see -2 into 2, 4 minus 4 plus 4, 0, -2 into 2, -4 plus 0 is -4, and minus plus 2 plus 4, I have 6. Again, I want to kill the element this in 3 1 position at 0. So I will multiply -3 by 2 to first row and I will add it to third row. So see 2 getting cancelled, -3 plus 3 I am getting 0. Again 2 getting cancelled. I have -3 plus 4, that is 1. Again you have minus getting cancelled, 3 by 2 plus 4. So 3 by 2 plus 4. So 4 to the 8 plus 3, 11 by 2. I have here entry as 11 by 2. So what are the entries which I got? See, -2 is multiplied to first row, added to second row. So here I will write negative of this, and that is 2. Next, I multiplied -3 by 2 to first row and added it to third row. So its negative is 3 by 2. So I will write 3 by 2 here. And lastly, I am worried about the position in 3, 2. For that, I will multiply 1 by 4 to second row and I will add it to third row. So I am getting 2 to minus 1, 0 minus 4, 6, 0. Here also I am getting 0. So here you will get 6 by 4, 6 by 4 plus 11 by 2. So if you add 12 plus 11, oh sorry, this is 4. So 6 plus 22, that is 28 by 4, and 4 7 are 20. So here I will get 7. Okay. I will get this. So what is the operation? What is the multiplier which is used? Multiplier which is used is 1 by 4. Its negative is minus 1 by 4. So this is your U and this is your L. Right? U has all the elements below diagonal 0 and L has diagonal elements 1 and above diagonal elements at 0. Okay? Is it clear to all of you? Is it clear?
Yes, sir.